Ground gas closeouts. Falcon Heavy is in startup.
All right, we're in startup, which means we're about to go for launch. We'll see a big green flash of the ignition before the ignition of the rockets. And that's how you'll know we're going to space.
SpaceX launch director, go for launch.
All right, 40 some seconds, we're ready for launch. Again,
T-minus 30 seconds.
I'll just be quiet and kind of let the rocket do this action here.
$15 T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, engine full power, and liftoff. Go SpaceX, go Falcon Heavy, go NOAA, go NASA, and go you. Vehicle is pitching downrange. Engine chamber pressure is nominal.
And again, here, climbing skyward. So difficult here.
Power and telemetry nominal. Falcon Heavy is supersonic. Max Q.
Right now, max Q one day. I'm practically right now walking through the closest stream close to the atmosphere. Just
side booster separation confirmed.
all right.
And back chill.
Side boosters just separated.
PYNY boost back startup. All vehicles are following nominal trajectories.
You can see the two side boosters that were on the center of the rocket now boosting back and heading back to Kennedy Space Center after their short little hop into the skies, but they gotta bleed off all the extra speed to get back to Kennedy Space Center to go the other direction. So that's what those boosters are doing. This booster you see right now on the camera is going to burn up eventually.
NY boost back shutdown. PY boost back
And that is
shutdown.
the engine bell of the second stage.
Miko. Stage separation confirmed.
All right, so we have stage separation. And we should have ignition of the second stage.
And ignition.
Yep, and there's second stage. All right, I think we lost the center core, but that's what it's designed to do. It's not meant for reuse, at least on this launch.
All vehicles continue to follow nominal
That
trajectories.
orange glow to the engine
separation
is
confirmed.
standard. And we're back now. This is another view of the side one of the side boosters slowly making their way, not slowly, quickly making their way down to the back to Cape Canaveral. They're kind of thrusting and making sure they're right on the right trajectory, kind of like a dart making its way back to Cape Canaveral. It's probably getting lower now. That's why
Stage 1 FTS is saved.
Each of these rockets all have a little bit of an explosive charge on them in case something goes wrong, so they can cut the boost, destroy the booster if there was a problem. Thank goodness right now there is not a problem. Excuse me. That's what the FTS is there for. I believe that little flashing thing is still the booster, but you can't see it. But I think that is it. As it gets closer and closer to the Cape. And there's
PYNY entry burn startup.
There's the entry burn. It's called supersonic retropropulsion, and it uses this ignition of these engines is actually making its own little heat shield, sort of. It's kind of blocking the rocket from the
PYNY entry burn shutdown.
Okay, so the entry burn is done, but it was basically blocking out the heat of re-entry.
PYNY FTS is saved.
Some physics of I don't completely understand, but it basically protects
all vehicles continue to follow nominal trajectories.
All right, there's the booster, at least one of the side boosters, and you'll see it ignite their landing burn in just a couple seconds here. It's coming down.
PYNY transonic. Stage 2 FTS is
transonic regime. It should be igniting at least one single engine, if not two of them.
PYNY landing.
All right, there we go.
Stage 2 is in terminal guidance.
There we go. Now it's kind of a dual landing. One goes a little bit first for the other one.
PYNY landing confirmed.
And there we go. There's the two side boosters. The fairing will be recovered by out in the ocean.
Seco.
So at least second engine cutoff has occurred. So there'll be a
Nominal
brief
orbit
coasting
insertion.
phase. Well, that's good. So then the GOES-U and the second stage are now in Earth orbit. But remember, but this launch has to go to geosynchronous orbit. So this will have to take a little bit more than just a normal orbit. There's a little more to that. So geosynchronous, if I believe is correct, is that it's in sync with a certain point on the Earth the entire time. So not geosynchronous, geostationary. It'll be in a geostationary orbit, so that it's basically looking at the same plot of land, even though it's orbiting. So, which means it's kind of a farther out orbit. It's not a near low Earth orbit. It's kind of a farther out one. So this is why it requires more than just one engine burn. So it can reignite for another